This video we're going to answer the exercise problem. Prove that the sum of the first n powers of 2 can be computed by 2 to the n minus 1. First off, we need to understand the left hand side and perhaps understand what is the n. So in this case, we have already a property 2 to the n minus 1, and that is supposed to mean that you have, for example, 2 to the 0, 2 to the 1, and so on. So you'll have powers of 2 to equals to 2 to the n minus 1. But what is this? What is this n? This n can be considered as the number of elements. So for example, if we try to have 2 to the 0, you'll have 1. So the property will be 2 to the 1. So you have 1 element minus 1, you'll get a 1. If you have 2 elements, 2 to the 0 plus 2 to the 1, you'll get a 3. So 2 squared, 2 elements minus 1, you'll have a 3, and so on. So therefore, if you have k elements, since this one started with 0, the kth element will be k minus 1. So again, that is because it started at 0. So the property really will be 2 to the 0 plus 2 to the 1 plus, and so on, up to 2 to the n minus 1. That is equals to 2 to the n and then quantity minus 1. So this is what we will be proving by induction. First off, the base case. So in the base case, we're going to prove the p of 1 is true. In this case, the p, that there is one element, should be true, and the first element is 2 to the 0, and that should be equals to the right hand side where n is 1. Again, this is one element, that is element. So that is 2 to the 1 minus 1, and you'll get 1 is equals to 1. Of course, you could prove it with 0 as well. When there are no elements at all, then this should be 0. So 2 to the 0, or 1 minus 1 is 0, and then no elements, you have 0 as well. So 0 equals 0. So second step will be the inductive step. Or basically the direct proof of the existence of pk should imply pk plus 1. So in this case, you have p sub k, so assume this to be true, p sub k, and that will give us 2 to the 0, 2 to the 1, up to 2 to the k minus 1. So that should be equals to 2 to the k minus 1, or minus 1. What we're trying to prove here is pk sub 1, which will be equals to 2 to the 0 plus 2 to the 1 up to 2k minus 1, and the next element of k minus 1 is 2 to the k. Then this should be equals to 2 to the k plus 1, the next element, then quantity minus 1. So with this we could substitute so 2k minus 1 plus 2k is equals to the right hand side. So we could continue it at the top. We could basically add 2k and 2k, giving us 2 of 2k minus 1 is equals to 2k plus 1 minus 1. And simplifying this will give us 2 to the k plus 1. So this is now shown by induction to be true. That's it.